Hello guys, welcome once more to another video on our YouTube channel. So in this video we look at the West Regional Mock Examination of 2024 Physics Paper 2. We are going to be solving one of the interesting questions that was there in section a question from projectile motion. The question reads, a ball is kicked from a horizontal ground towards a vertical wall as shown in the figure 1 below. That is the figure. The horizontal distance between the initial position of the ball and the base of the wall is 24 meters. The ball is kicked with an initial velocity u at an angle of 28 degrees to the horizontal ground. The ball hits the top of the wall after a time of 1.5 seconds. Air resistance is negligible. A. Calculate the initial horizontal component ux of the velocity. B. Calculate the time taken for the ball to reach its maximum height above the ground. And C. Calculate the maximum height above the ground. Alright, so let's get started with the solution. Okay, so we have three questions here and I'll be very brief and very explicit with my solutions. First question, we need to calculate the initial horizontal component of the velocity of the ball. So the ball was projected, according to the equation, it was projected from the horizontal ground, and there was an angle that the initial velocity makes with the horizontal. It is 28 degrees. So according to the equation again, it is hitting a vertical wall, the top of a vertical wall, which is at a distance of 24 meters from the point of projection, and the time taken to cover this horizontal distance is 1.5 seconds. So we are going to use the relationship between the initial velocity in the horizontal direction, the horizontal distance traveled, and the time taken to travel that horizontal distance. So generally we have the Newton's laws of motion. We are going to use S equal to ut plus half at squared. But now when we are in the x direction, we are going to call S as sx, we are going to call u as ux, we are going to call a as ax, we are going to call t as t because tx and ty are all the same, and the t was given to us as 1.5 seconds, pardon. So it means that sx will be equal to ux t plus half ax times t squared. But in the horizontal direction there is no acceleration, so it means that your sx will just be equal to ux times t. But what is sx after a time period of t? Your sx is 24 meters after a time period of 1.5 seconds. So I just have, this is a vertical, initial vertical, this is the initial horizontal, so this ux is what we are finding. So from there we just have that 24 is equal to ux times 1.5 because 24 is sx after a time period of 1.5 seconds. So what is ux? 24 divided by 1.5, which will give us 16 meters per second. Question B, find the time to reach the maximum height. So first of all, we need to come to the diagram and try to indicate the maximum height. So this is the position of the maximum height, and this maximum height is the height above the ground. Now at maximum height, the vertical final velocity of the ball is 0, and with that we use the equation of motion that says that v is equal to u plus at. But since I'm involved with the vertical component, I will have vy is equal to uy plus ay times t. So we have uy plus ay times t is equal to 0. But in the vertical direction, since the ball was moving against gravity and air resistance was negligible, then your acceleration in the vertical direction is just negative of the acceleration due to gravity. So it therefore means that we have uy minus gt equal to 0. So from there, what is t? Your t is uy divided by g. What is uy? The initial velocity in the vertical direction of the ball. Now, how do I get this initial velocity? If I resolve the component of this initial velocity, I'm going to have that uy is actually u sine 28 degrees, while ux is actually u cos 28 degrees. So our uy is equal to u sine 28 degrees. having that ux is equal to u cos 28 degrees, right? It therefore means that our 16 meters per second will be equal to u cos 28 degrees. Now what is u from there? Our u will be 16 divided by cos 28 degrees. So my uy will be equal to the u that we have here multiplied by sine 28 degrees. So I'll just have to take the 16, then I multiply it with sine 28 degrees, then I divide it by cos 28 degrees. Doing that, we are going to have 16 sine 28 on cos 28, which will give us 16 tan 28 degrees. So what is t? Our t will just be equal to 16 tan 28 degrees divided by g. So you can punch and tell me your answer in the comment section. If I like your comment, it means that your answer is correct. If I dislike your comment, I'm going to give you the correct answer as well. Now let's go to the last part, which is saying that, so this time here is a time to arrive maximum height. Now the last question is asking us to find the maximum height itself. So since we have the time to arrive maximum height, and the maximum height is a vertical distance, we are going to use sy equal to uyt plus half at squared. Now let's get some important informations. First of all, our uy, we found it already as 16 tan 28 degrees. What about our time? The time we already found it as 16 tan 28 degrees divided by g. Okay, that is the time. And what next do we need? We need ay, which is negative g. So I think with this you can just substitute everything back into the formula, okay, and then you have exactly what the maximum height is. So I think when you substitute, you're going to have 3.6 something. Okay, so tell me your answer in the comment section. Alternatively, to solve this question, we could also use the fact that at maximum height your vertical velocity is 0. Then we use the other equation of motion, which says v squared, okay, is equal to u squared plus 2as. All right, plus 2as. Now we are going to replace our v here with vy. Okay, you replace your u here with uy, you replace your a with ay, and then you replace your s with sy. Now if you call vy to be 0, then it means that your sy will be the maximum height. Okay, your ay will normally be negative g, and then your uy is what we had here, 16 tan 28 degrees. So I'm waiting for your answers in the comment section. Make sure you like, you subscribe, you like the video, you subscribe to the channel, you also share, and your comments are very important to motivate me. Thank you guys for watching, and see you guys in the next video.